Hello guys, my name is Mohammad Izhaan Khan. Currently, I am pursuing my degree in Bachelor's from Civil and Environmental Engineering from IIT Patna. So today we are going to start the topic on physics, dual nature of radiation and matter. So uh, I don't think that I need to give you any overview regarding this chapter, but let's see. I'll tell you the basic concepts, and that will be a revision part. And it is like a waste of time for me to um, get you the gist of the whole topic for the first 1 hour and then solve the questions for the same. So you just revise through the questions. Okay, I'll tell you the concepts wherever required. So moving onwards, the first question number one. So a particle is dropped from a height h. The d Broglie wavelength of the particle as a function of height h is proportional to. See, basically, what you need to understand is in the latter part of your physics, like the chapters which are at the end of the class 12 notebook, they are highly conceptual. Okay, so in these questions, you need to know the concepts and you need to know the basic gist of the topic. It is not that you require to do hundreds of questions to get the skill. It is that you need to know the concept, basic concept. That is what will help you in the exam as well. So now, according to de Broglie, a moving particle sometimes acts as a wave and sometimes acts as a particle. Okay, so the wave associated with a moving particle, that wave is called what? Matter wave or de Broglie wave, and it propagates in the form of packets that we all know. Now, the like if I ask you to write the wavelength for de Broglie is 2g capital H. Okay, and de Broglie wavelength lambda is equals to h upon p. Okay, so this is the velocity v. Okay, now lambda is equals to h upon mv. So h upon n times v 2g h. So lambda is proportional to what? 1 upon under root of h. So it is 1 upon h 1 by 2. So it is h minus 1 by 2. So lambda is proportional to h raised to the power of minus 1 by 2. Okay, so moving onwards, question number 2. Okay, so the wavelength of a photon needed to remove a proton from a nucleus, which is bound to the nucleus with 1 mega electron volt. This is how you read it. It is mega electron volt. You know this part? Mega, you know. Okay, it is 10 raised to the power of 6. So the key concept behind this is okay. So now, do you recall the energy of photon? E is equals to h times nu. This you can recall, right? This is the energy of photon. Only. Okay. And if I write it, hc by lambda. So this is Planck's constant. This is speed of light. What will be the unit? The SI unit, meter per second. And what is lambda? Lambda is the minimum wavelength of the photon that you have to calculate in this question. So basically, this is the wavelength, right? So E is equals to hc by lambda. Now, in electron voltage, we have to calculate. We have different forms for it. Like you can write it as 12,400. But in this case, your lambda that you put in here should be in angstrom. So basically, you put the value of h. H is what? 6.6 into 10 raised to the power of minus 34 joule per second. Joule second, I'm sorry. And C is in meter per second, 3 into 10 raised to the power of 8. So you put these values, and when you put lambda in angstrom, then you get the SI unit for energy. So these are basically just to make your work easier, because usually lambda is in angstrom, it is not in meters. Okay, or in nanometer, things like that. So Solving from here, so lambda will be equal to hc upon e, and it will be 1240 because lambda is in, we have to calculate in nanometer, and the energy given was 1 mega electron volt, right? Yeah, so energy is 10 to the power of 6. So what will be our answer? It will be 1.24 into 10 to the power of minus 3 nanometer. So 1.24 10 to the power of minus 3. Yeah, option number B is the correct answer. So moving onwards with question number 3. So they have asked us to consider a beam of electrons, okay, incident on a metal surface kept in an evacuated chamber. So if I draw it, it should look something like this. I'm sorry. Okay. So there is a disk right here, and there's a disk over here. See, the electrons are in this disk, but they get popped out. You know the whole mechanism behind it, alright? So I'm just going to tell you what is happening. And it is moving forward and hits this metal plate. So in the question it was given that we have to consider a beam of electrons. Beam is what? These electrons moving at a high speed. Again, each electron with an energy of E naught per electron. Alright. Now it is incident on a metal surface which is kept in an evacuated chamber. Okay, so this is an evacuated chamber. This is the metal surface that they have asked us in the question. So now we have to tell no electrons will be emitted as only photons can emit electrons. This is option number 1. Option number 2 is electrons can be emitted but all with an energy E naught. Okay, electrons can be emitted with an energy. Okay. So let me just tell you the basic concept, right? So okay. So option D is correct, right? Like if you see, if a beam of electrons having energy E naught is incident on a metal surface which is kept in an evacuated chamber as it is given in the question itself, so the electron can be emitted with maximum energy E naught. Okay, due to elastic collision. See, the electrons are moving towards the metal surface with initial energy E naught. And जो energy electron के पास होगी after its removal, it should cross the threshold energy. Okay, so the energy that an electron which is getting out of the metal surface will have any energy which is less than E naught. Okay, with a maximum of E naught, as it is stated in the option number D. See, I show you. Suppose this is a metal surface and it has electrons in it. Okay, but I say that the energy required to take out an electron from here is, let's say, 1 electron volt. Okay, it is an arbitrary number. Okay, so don't this is not an exact value. Just think it like that. And if I put an incident electron over it with an energy of E naught, then the electron which is emitted from over here will have a max of E naught minus 1, because 1 electron volt has been used up in getting this electron free from this metal surface, and the rest energy may be transmitted because what happens is collisions happen, so energy is decreased, but we can say that the maximum of it will be this value. All right, so this is the concept. So the correct option for it is option number D. Now question number 4. So we have to consider a figure. All right. Okay. But I don't have any figure over here right now. So we can do this afterwards after I see what figure is there. Okay, because you have to open the NCERT textbook for this because the figure is not given over here. Now, moving onwards to question number. What question do you have? Question number 5. Yes. So there's a proton, a neutron, and an electron. Okay. Proton, neutron, electron, alpha particle is same energy. and the de Broglie wavelength compared as. See, these are basic questions, or like you just need to know the formula for it. It is like that. So I told you de Broglie wavelength lambda is equals to h upon E. Alright, alright. See, kinetic energy is equals to half mv square. 2En is equals to m square v square. So mv is equals to under root 2m. Alright, this is what I've done over here. Okay, so this means that lambda is inversely proportional to 1 upon under root of E. Now, in the question, it has been given to us that proton, neutron, electron, and an alpha particle have same energy. Okay, then the de Broglie wavelengths can be compared as what? Okay, now we have to consider the mass. Okay, because see, energy is constant, so we cannot differentiate all these particles on the basis of their energy. Now we see that mass is also there, so lambda is also inversely proportional to 1 upon the root m. Okay, so lambda proton, lambda neutron, lambda electron, and lambda alpha particle will be 1 upon under root mass of proton to the ratio 1 upon under root mass of neutron, mass of electron, and mass of alpha particle. So now you just have to plug in the value. So now you know mass of alpha is greater than mass of proton, and mass of neutron is greater than mass of electron, and electron and proton are the same mass. No, proton and neutron have the same mass. Okay, so the correct answer will be option number proton equal to neutron. Option number B will be correct. You just have to compare the masses. Alright. See, lambda is inversely proportional to 1 upon under root n. So you just have to put in the mass to get the value for lambda. Next up, we have question number 6. Question number 6. So an electron is moving with an initial velocity. Initial velocity is v is equals to v naught I gap, and is in a magnetic field. V is equals to v naught j gap. Then it's de Broglie wavelength. Okay, we have to talk about the de Broglie wavelength. So options are remains constant, increases with time, decreases with time, and increases and decreases periodically. These are the options over here. So the correct answer is de Broglie wavelength will remain constant. And why will it be? So I'll just tell you a basic concept over here. See, if a particle is carrying a positive charge q and moving with the velocity v, then let me just draw it over here. See, this is the v. Okay, going inside the screen. This is the magnetic field. Alright, and see, I'll draw the axis over here. So this is one axis, this is x, this is z, and y is going inside. Alright. Now, what happens is, suppose there is a positive charge q with a charge of q and a mass of m. Alright, with a velocity v, and it enters this magnetic field. Then it experiences a force. Alright, in what direction will it be? V cross V. V cross V inside. So thumb will be upwards. So this will be the direction of force. What will be the value for this? Q times V character crossed with magnetic field character. V cross V. Alright. So this is the force that it will experience. So in the question it was given to us, an electron moving with velocity and having this, then it's de Broglie wavelength. But this force does not increase the velocity of the object. Okay, this force does not increase the velocity of the, like, how can I explain it to you? So this force is perpendicular to V. So the magnitude of V will not change. This you can understand, right? See, V is right here, perpendicular to V. So magnitude of V, magnitude does not change. But what does it change? Since it is an acceleration, it will change something. It changes the direction. So if it changes the direction, then it changes the velocity. That is why it is an acceleration. What's the point? So acceleration doesn't necessarily always increase the magnitude of velocity. It has to change the velocity. How can it change the velocity? By changing the magnitude as well as changing the direction. So it is a very important concept for you to know. And many people don't know this concept, alright? So it is an important one. So the magnitude of V will not change. Now, if the magnitude of V is not changing, then the momentum mv will remain constant. So since that is remaining constant, then what is my lambda is equal to h upon mv? Since this is remaining constant, then lambda will remain constant. Simple. Basically, what happens is I'll tell you a misconception. So the misconception regarding this is if this is a positive charge moving some velocity v, it enters a magnetic field V region. Okay, so what happens is velocity V is over here. Force is equal to Q V cross V. So people think that since force is acting, the velocity must be increasing because force makes acceleration makes the velocity increase. But acceleration does not always increase the magnitude of velocity. It can also change direction while keeping magnitude of V constant. Note down this concept, alright? It is a very important one. Now, question number 7. An electron of mass m with an initial velocity v. An electron with a mass of m with an initial velocity v naught I cap is an electric field. Its v Pauli wavelength at time t is given. Alright. Can I write the lambda initial at time t equal to 0? It is equals to. Okay, this is the initial. What force is acting on the electron? Q times E. Okay. So I can write it as minus E. Since it is an electron and minus E naught, direction is I cap. So it is E naught I cap. This is the force that is acting on it. And acceleration will be E naught by M I cap. After time t, the velocity of the electron will be after time t, velocity will be v at time t is equals to v naught plus acceleration times t. So v naught plus acceleration is e naught by m. Okay, multiplied with time t, and these both are in I cap direction. Times t whole is in I cap. So writing down the velocity is v naught I cap plus e naught upon m I cap times t. Alright. So v, if I write no, I don't need to write it again. H upon mv. So lambda will be h upon v naught plus e v naught h upon mv naught. If I take constant, 1 will be over here and E E naught T upon M V naught. So this is the lambda initial. Lambda naught. Lambda will be equal to lambda naught whole divided by 1 plus E E naught T whole divided by M V naught. Moving forward, so we have done this is what question number 7. Alright. So I hope you understood this question because it was a basic question. So now we have question number 8. So in question number 8, an electron with a mass of m with an initial velocity v equal to v naught in I gap is in an electric field. तो इलेक्ट्रिक फील्ड कहाँ है जी गैप है और लाइक सो एक लैम्डा इनिशियल दिया हुआ है लैम्डा नॉट it is h upon mv naught. It's d Broglie wavelength after time t. Similar question, just like the previous one. So let's start question number 8. Okay. So initially lambda initial was h times m v naught. All right, all right. Now force acting on the electron, right? It is a vector minus e times e cap, but direction of e is in j cap, right? So I'll rather write it as this. Okay. So this is the force which is acting on the electron. So the acceleration acting on the electron is minus e j cap. Alright. So this is the acceleration which is acting on it. Now this acceleration is along the negative y-axis. Okay, okay. And the initial velocity v naught is in I cap. Alright. So as you can see, v is like this, acceleration is like this, only perpendicular to it. Now the component of velocity will remain constant as there is no force in the direction of propagation of the electron. See, this is 90. Take cos 90 is 0. So this acceleration is having no effect on this velocity. The magnitude of this velocity remains constant. What changes is the direction. See, this is acting as a centripetal acceleration. So it starts going like this in a circle. But the magnitude of this will remain constant, unchanged. Okay. So in the x direction, there is no change. Now we have to consider along the y direction. Along y, velocity is equals to 0 around y. Like if I write vy, that is equals to 0. Vx or something, vy equal to 0. But acceleration along y is there. What it is equal to e naught upon n with a minus. Okay, because this is minus j. Okay, okay. Now I have to write vy. V is equals to u plus 80, so 0 vy plus 80. Acceleration is minus e times e naught upon m times t. So vy I can write it as minus e times e naught upon m t j cap. Alright. Now the magnitude of velocity you have to find out because now there is a velocity along x and there is a velocity along vy. So these are two components for a velocity which must be going like this. Now this is the velocity that you use over here. So now you write it as lambda is equal to h upon 4 n under root of ex square plus by square. Simple. H upon m under root. Now b naught square plus minus e times e naught upon m t whole square. Alright. So v naught 1 plus e square e naught square t square m square v naught square. Now the de Broglie wavelength was initially what? Lambda dash is equals to h upon n v. Now if I write it like that, so it will be h upon n v naught. I'll take out common 1 plus e square e naught का square t square upon n v naught का square. ठीक है. So this part is what? This is lambda naught. So the correct option will be what? E square E naught square T square upon M square B naught square. M square B naught square. So which option is correct? Option number C. Uh, Option C is the correct answer for this. Okay, so these are basically questions which have more than one correct answer. So these are the best kind of questions because you have to analyze each of the four. In most of the questions, you have to analyze, like some questions have contrasting options. Like if one is correct, that is always wrong. It is like that. But in some questions, they design it like that. Or you have to check all the four um, options which are given to you. So that is the beauty of such kind of questions. So, relativistic corrections. Okay, relativistic corrections become necessary when the expression for the kinetic energy E equal to 1/2 mv square becomes comparable with mc square. Okay, where n is the mass of the particle. At what t Broglie wavelength will relativistic corrections become important for an electron? See, in the first half of the question, they are giving you the condition where the relativistic corrections should be applied. Okay, then it should be applied when half mv square is comparable to mc square. So this is the condition that they have given to us. So v square upon 2 is comparable to c square. Okay. When the phase, so this means that when the phase velocity is greater than the speed of light, then okay, so that is just conceptual part. So if you have to solve it, lambda will be equal to h upon p, it will be h upon mv. Now the value for h is 6.6 into 10 raised to the power of minus 34 joule seconds. And the mass of an electron used to be what, 9 point something, let's say 9, minus 31 kgs. Alright, so to approach these type of problems, we have to use hit and try methods. Like we have to check for each options. So I'll just show you how. So let's say in option number A, they have given that lambda 1 is equals to 10 nanometers, which I can write as 10 raised to the power of minus 8 meter. Simple. Now V1 will be equal to 6.6 into 10 raised to the power of minus 34. The value for h, the value for mass will be equal to this, and okay. So solving this, okay. So it is in the range of 10 to the power of 5 meters per second. No, this is not the condition for it. So option A is wrong. Now we'll check the velocity for option 2. See, when we say when the velocity that is coming, the phase velocity, that will be greater than the speed of light, then we'll just say like greater than or comparable to. Then we will say that yes, relativistic corrections should be applied over. But when it is less than, like say, suppose you have a velocity of 100 km per hour, and somebody is moving with a velocity of some snail, or some insect is moving with a velocity of 1 km per hour, and you're moving 100 kilometers per hour. Then it does not matter. It appears at rest. Okay, so at rest to you, because this is incomparable. Now, what was happening over here was 10 raised to the power 5 was the velocity of the phase, and for the relativistic correction, it should be 3 into 10 raised to the power of 8 meters per second. See, it is just like you are moving with a velocity of 1000 km per hour, and some insect is moving with a velocity of 1 km per hour. Okay, so this is incomparable. It is like that the other thing is just at rest. Okay. Now, option number B. Now, lambda is equals to 10 raised to the power of minus 1 nanometers. So, it is 10 raised to the power of minus 10 meters. Now, V2, if I write 6.6 into 10 raised to the power of minus 34. Now, writing the mass for it 9 into 10 raised to the power of minus 31 into 10 raised to the power of minus 10. Okay. So, okay. 41 plus 7. Okay. So it is in the range of what? V2 is in the range of 10 is to the power of 7 meters per second. Okay, so option C, I'll say that it is in that range. I'll take it. Now moving forward with option number B. No, no. Option, which was it? Option number B. 10 is to the power of 7. No, 10 is to the power of 7 will not fit that criteria. It has to be till 10 is to the power of. This is option number B. This is also wrong. Now checking for option number C. I know that C is small enough to give us the value which is required. So we have to find P3. 6.6 into 10 is to the power of minus 34 whole divided by 9 into 10 is to the power of minus 31 into, in option number C, it is 10 is to the power of minus 4 nanometers. That means 10 is to the power of minus 13. Okay. Minus 44, 10 is to the power of 10. Now you see, V3 is coming in the range of 10 is to the power of 10 meters per second, which is greater than the speed of light. So relativity corrections will be applied over here. So C option is correct. Now, obviously, it is, you can see that since lambda equal to h upon mv, v is inversely proportional to 1 upon lambda. So since lambda is decreasing, v is increasing. So if for lambda is equal to 10 is to the power of minus 4 nanometer, v is greater than c, then for a smaller value of lambda, the v will be greater. So option D will also be correct. You don't even have to solve the last part. Like if you want, you can solve and see for yourself, but it is just common sense. Now, question number 10. So there are two particles. Okay, A1, A1 and what? Okay, so it's a misprint. There are two particles, A1 and A2, which have masses M1 and M2 such that M1 is greater than M2. Now, if the two have the same de Broglie wavelength, then you have these four options. So let's check. So we know that de Broglie wavelength lambda is to h upon mv, where mv is the momentum. So h upon p. Simple. Till here we know. So since every all the both the two bodies have the same de Broglie wavelength, that means they have the same momentum. So their momenta are the same. So option A is correct. Okay. Now moving onwards, we have to check for what? We have to check for energy. Okay. We have to check for energy. So to check for energy, what can we do? We know that momenta are equal. So P1 is equal to P2. Okay. And energy I can write as half mv square. Yeah. So P square by 2m. Okay. So energy will be inversely proportional to the mass. ठीक है. जिसका mass ज़्यादा, उसकी energy कम. And we have over here that mass m1 is greater. That means E1 will be smaller than E2. Okay. जिसका mass ज़्यादा, उसकी energy कम. So m1 is greater. That means E1 is lesser. Simple. So E1 will be less than E2. The energy of A1 is less than the energy of A2. Correct. Option C is also correct. So A and C are the correct options for this question. Now, what do we have? The next question is question number 11. The de Broglie wavelength of a photon is twice the de Broglie wavelength of an electron. Okay. So, photon is 2 times the de Broglie wavelength of an electron. Speed of an electron is C upon 100. Then you have to compare the energy of the photon and the electron. Okay. So the energy I can write it as half times mv square, which is also equal to q times v, where v is the potential difference and q is the charge. Okay. Charge multiplied with potential difference. Okay, so now the d probability wavelength lambda is equals to h upon p, which is equals to h upon under root of 2 me, which is equals to h upon under root of 2 mqv. Now, I'm writing some um, like these are also the ways that we can describe it. So for electron, I can write it as 12.27 upon under root v times the angstrom, and for lambda proton, 0.286 upon under root v. Write these in front of your desk. Okay, write these on a paper and stick them in front of your desk. So you read it as many times as you can, because these are very important formulas. Okay, and the best part about these formulas is in the exam you don't have to think a lot. You just have to put the values. Like some questions will be there that you have to just put the value for b over it, and you'll get the answer in angstrom. Okay, so it is very good plus four in mains. So that is what I'm saying. Lambda deuteron also you have to remember it is 0.202 upon under root 3 angstrom, and lambda alpha particles. See, these four are very important. Lambda alpha is equals to 0.101. Deuteron alpha is this under root 3 angstrom. So now the d probability wavelength, which is associated with charged particle for neutron. For neutron, I can write it as lambda neutron is equals to 0.286 upon under root of E. In electron volt, you have to put it, and I over a angstrom. So energy is equals to KT, which is under root of 2, and KT, which is the absolute temperature. Okay, and K is the Boltzmann constant. I hope you know this. Boltzmann constant. Okay. So calculations. So for lambda neutron, 6.6 into 10 to the power of minus 34 under root of 2 into 1.67, the mass of electron, into 1.38, and this 2 10 to the power of minus 23. 23, yeah. So let's calculate this. Wait a minute. I calculate it. 30.83 upon under root T angstrom. Alright. Now, the d probability wavelength for electron will be HMeVe. Okay, so lambda electron will be HMeC by 100. Okay, so 100H upon MEC. So kinetic energy of MEVE का whole square. So MEVE is equal to under root 2 EE. Now lambda is equal to H upon MEVE. So H upon whole under root of 2 MEEE. Now energy E equal to H square upon 2 times lambda A का whole square upon ME. No, this time. So E proton is equals to Hc upon lambda p, which is Hc upon 2 times lambda E given in the question. Now E proton upon E electron will be equal to Hc upon 2 lambda E. Okay, into H square 2 lambda E whole square ME. So lambda E MEC upon H. So 100H upon MEC into MEC upon H. 100. So EE upon EP. EE upon EP will be equal to 10 raised to the power of minus 2. EE upon EP. So option B is correct. And moreover, option C is also correct. Check it. See, P is equals to MEVE and MEC upon 100. Okay, so what is given over here? EE upon MEC is equals to 1 upon 100, which is equals to 10 to the power of minus 2 as it is given in the question. See, so option C is also correct. So B and C are the correct options. Very good question, this one. You can mark it important. See, it is using all the concepts that are important for this chapter. Now, question number 12. Photons absorbed in a matter are converted to heat. Okay, a source emitting n photons per second of frequency mu is used to convert 1 kg of ice at 0 degree Celsius to water at 0 degree Celsius in the time taken t. Excuse me. I'm sorry. So let me just tell you one thing. These kind of questions where they're using concepts of different chapters, these are the best kind of questions that you can think of. Alright, why? Because they use the basic concepts. They don't use those advanced concepts. They use the basic concepts to different chapters and they just club them. If I give you a question and I'll ask you that how much energy will be required to convert 0 degree ice to 0 degree water, it is a simple question for me, right? If I just ask you that how much energy will be required, how much energy will be emitted if the photons are just this, and this. That is a simple question for this chapter. So these two simple questions are just clubbed together and they are made into another question. So these questions are great. Like these are very easy questions. That is what I'm telling you, and you have to trust. You don't have to worry that whenever you see that we have not seen anything like this before, how will we solve this? It is not like that. They are basic questions. So question number 12. We have seen that what they are saying. So now, how will I do if I get this question in exam? I'll just tell you. So I just take out the E absorbed, the absorbed energy. It will be what? If I remember it, it is mass into latent heat, right? Latent heat because there is a phase transformation. So ml, I can write it as m times L, and they have not given over here, but in question you will be given the value of L. So as I remember, the value for L for the conversion from ice to water was 80 calorie per grams. Okay. In the question, they will they'll give it to you. You don't have to worry. Like you don't have to cram up these values. All right. So mass is 10 is to power of 3 grams and 80 calorie per gram. I'll be left out with 8 into 10 is to power of 4 calories. So this is the energy which is absorbed. Okay, part. The heat part is over till here. Heat part is over. Now starts the part for the dual nature, the de-Broglie part. Okay. So energy of the photons used. Energy of the photon used will be what? N times T, N T, and E. So N T electrons per unit time into E. So E will be H nu. Okay. So N T H nu equal to M L. So T will be equal to M L upon H N U. Okay. All right. So first of all, now I have to check the options. So the time taken T. Okay. So we have a M H upon M H. Okay. So we didn't have to solve for M and latent heat L. So that is why no value was given for it. All right. So don't worry about that. Only this part is important for the question that is given to us. Now we put the time taken T will decrease with increasing in. No. Yeah. Time T will decrease as n is increasing because they are inversely proportional. So option A will be correct. Now checking option B decreases with n fixed V increasing. Time T will decrease with V increasing. Since V will increase, T will decrease. C is also correct. Now check option number C. So remains constant with n in V, changing such that n V is equals to constant. So option number C is correct. Maybe let me check. So if I take n V as constant, option C is n nv को अगर constant करने और like so then other factors are there and so time taken for conversion decreases with increasing v. That is different thing. Hmm. P is constant when NV is constant. That part is correct. So remains constant when NV is equals to constant. I think that is what they're asking. So option C is also correct. Now checking for option B. Increases when the product NV increases. So if the product NV will increase, T will decrease. So the option is wrong. Okay. So moving forward, question number 13. Okay. So a particle moves in a closed orbit around the origin due to a force which is directed towards the origin. This is how particle moves. This is the origin. See, it is not an ellipse. It is a disc shape, and you are just seeing the isometric view of this. Like you are looking at it from an angle. If you look at it from vertically upwards, it will appear as a disc view. Alright. Now this particle moves in a closed orbit around the origin due to the force which is directed towards the origin. Okay. So at every point, the force is directed towards the origin. This is important. Okay. The d probably wavelength of the particle varies slightly between two values, lambda 1 and lambda 2, with lambda 1 being greater than lambda 2. So which of the following statements are true? Okay. The particle could be moving in a circular orbit with origin as center. Mm-hmm. The particle could be moving in an elliptical orbit with origin as its focus. Since lambda 1 and lambda 2 are different, see, if it is a circular path, case 1, I'll tell you, for circular path. A circular path is like this. Okay, every part, the distance from the center to the circumference is constant and is equal to r. So velocity is also the same at every point. So if velocity is same, lambda is equal to h upon mv. Lambda is inversely proportional to 1 upon b. So if v is constant, then how will you get two different lambda 1 and lambda 2 say that lambda 1 is greater than lambda 2 as it is given in the question? See, this is not possible for circle. Got this point. Now, if I imagine another case, okay, if I manage another case, if I say that it is an elliptical orbit, that as it is given in the options. See, circular A part is from elliptic orbit. Let's check for elliptical. So this is an ellipse. Okay, this is a focus F1, this is a focus F2, and these both can act as the origin. So if I say that this is the origin for it, now got this. This is the diagram for it. Now, option B. Okay, so since lambda 1 and lambda 2 are different, if I say that this is near to it, I say that here it is V2. Then V2 shall be greater than V1, and due to that reason, lambda 1 can be greater than lambda 2. Alright, so option B is correct. What more have they given us? So let me even okay. So if I say lambda 1 is equal to h upon mv1 and lambda 2 is equal to h upon mv2 and lambda 1 upon lambda 2 is equal to v2, it will be equal to what? v2 upon v1. So lambda 1 is greater than lambda 2, then v2 will be greater than v1. So by law of conservation of angular momentum, the particle moves faster when it is closer to focus. That we already knew, and that is what I have proved over here. I considered this velocity as v2, and I have proved that v2 will be greater than v1. And also this proves the law of conservation of angular momentum, that the velocity will be higher near the focus of the elliptical movement. So is another option correct or what? When the d Broglie wavelength is lambda 2, the particle is nearer to the origin. Yes, it is correct. Because lambda 2 is less than lambda 1. That means that wherever the velocity will be greater, that will be the point where the lambda 2 is occurring. So option D is also correct. Short type answer questions. Okay, so a proton and an alpha particle are accelerated using the same potential difference. How are the d Broglie wavelengths held up in lambda alpha related to each other? Simple question. Lambda equals to h upon p. It is equals to h upon. Write this 100 times with me, alright? Because these are very important formulas. These interconversions are there, and then I told you, na, you just have to compare two values. So lambda is equals to h upon under root of n cube. So I can write it proportional to under root n cube. Rest all the parts are constant. Now to lambda for proton upon lambda for alpha. M proton Q proton times electron. Mass of proton into E. So under root 8 will be equal to 2 root 2. So lambda P is equal to 2 root 2 times lambda alpha. This is the answer. This is a very short answer only. Now 11 to 15. Okay. 15 is the first. In the explanation of photoelectric effect, we assume one photon of frequency mu collides with an electron and transfers its energy. Okay. So this leads to the equation of the maximum energy Emax of the emitted electron equal to HV minus phi threshold. And phi naught is the work function of the metal. An electron absorbs two photons, each of frequency mu. What will be the maximum energy of the emitted electron? Okay. So let's just do the question number part 1 first. So I'll just tell you the key concept. See, this is the plate from where electrons are emitted. Let's say this is the electron. Okay, I've drawn an electron over here. Now, what do? You put some energy equal to h nu on it. So when you do that, okay, so when you do that, this electron can be emitted out and move. So in that case, the kinetic energy it is having is the maximum. How is it maximum? The value for it will be hv minus the work function phi naught. And there is another electron which just gets out of the this metal sheet and stays at rest. The kinetic energy is zero. So why are there so many ranges? Like an electron can have a kinetic energy equal to zero, also can have kinetic energy equal to h mu minus phi naught also. So this is the maximum and this is the minimum. What happens is, think of it like this. There are many people. Alright, you are in a bus. You are traveling in a bus. Okay, see, this is a bus, and there are many people inside the bus, and you are right here. I give you a box of chocolates. Okay, I give you a box of chocolate and I ask you to get out of this door, and this whole bus is filled by students. But when you will be getting out, there will be you have to give at least one chocolate to the driver, at least one. Okay, so that one is the work function. That is what you have to. I give you 100 chocolates. You have to give at least one chocolate to this driver before getting out. So you gave one chocolate. How many chocolates will you have when you'll be out of this metal sheet or this bus? You'll have 99 chocolates. So this is the maximum value that you can have. Because there are chances that these students that are sitting over here, these students are there, na? These are the different electrons that you'll have to drift past. You have to give these chocolates to 1, 2, 3, 4, 5, 6, and like that. It can happen that although you give it one chocolate to the driver and this to all of them, and when you get out, you'll have 0 chocolates to yourself. So the maximum is 99 and the minimum for it will be 0. Okay, some energy may be lost in moving through the different electrons. Electron. One electron is facing a repulsive force from the other electron, and when you move through it, you lose some energy. Okay, so that is what I was trying to explain to you. So we have to solve this question, right? तो इस क्वेश्चन में हम लोग को दिया हुआ है, फर्स्ट ऑफ ऑल एट दिस राइट, k max is equals to half and v max का square. So this is the maximum kinetic energy of emitted electron, and I like w naught as the work function. Work function. Okay, so w naught is equals to h v naught is equals to h c upon lambda naught joules. So v naught is the threshold frequency, lambda naught is the threshold wavelength. Alright. So E max, as I already wrote, was h mu minus work function phi naught. Now, since you are taking out two electrons, it will be h2 mu minus phi naught. So 2h nu minus phi naught. So this is the maximum kinetic energy that you can use. So, and also the question number 2, why is the fact not taken into consideration in our discussion for the stopping potential? Okay, so the probability of absorbing two photons by the same electron, that is very rare. That is why like it is one in a million kind of probability is there for this. So that is why the emission, such emission will be negligible, and that is why it is not taken into account. So we have some questions left till question number 29. So the 13 questions are left. So I'll take up from there, from here, from in the next class. So I'll see you there. Bye bye, all the best.